Welcome to UPARS Los Angeles. This is March of 2016. We have a very, very interesting talk tonight. Dr. James Woodward, he comes to us from the Cal State Fullerton, where he heads up a physics lab there, and he looks into all sorts of interesting things, and he's going to talk about that. When you see a craft in the sky, if you acknowledge the reality of UFOs and how they move, they don't fly. I think the whole thing about flying saucer is a misnomer. These things don't fly like we fly through the air. These things translate through our reality in infinitesimal slices of time. And they use a propulsion they're not filling up at the gas station. They're not going to the Shell station and filling up. They come from who knows where. They appear here and then they leave. And oftentimes it's reported they phase in, phase out, or appear and then disappear. They move at extraordinary speeds with little or no friction observed. They change direction and course as if momentum, the laws of our physics don't exist for them. And so what could explain this? I mean, we were seeing this phenomenon occur from the beginning. Our military was reporting these things in the 40s and observing and reporting their movements. How can you explain this sort of thing? Well, tonight, hopefully, our speaker is going to give us a little bit of insight that will help us to understand how this might be possible. Without any further ado, please give a warm welcome, Dr. James Wood.
Thank you.
Does he need this? Dennis, does he need this mic?
Do you need this mic?
No. Okay. I'm going to take it away from you.
All right.
Excuse me.
Yes, that's fine. You've just heard a classic description of so-called flying saucers or UFOs and that sort of thing. I grew up in the 40s and the 50s and experienced a lot of the stuff that for many of you I expect is just history. By way of background, let me mention an incident which seems to be related to all of this. In the mid-50s, there was a science fiction film called Forbidden Planet, and the opening to the film was a flying saucer waffling along through hyperspace or what have you, and the overspeech was, and then at the end of the 23rd century, man figured out how to achieve the speed of light and then vastly exceed it, and so on. And I can remember as an ignorant and probably arrogant youth thinking, well, gee, if they can do it at the end of the 23rd century, why not try and do it now? I relate this because I mentioned this story to some friends at a NASA meeting a few years ago, and a good friend of mine immediately piped up, and then you spent the next 60 years finding out why they don't do it now. Okay, so you should understand that figuring out gravity control or gravity manipulation, whatever you want to call it, is something that's generally in our culture, but it's something that, for the most part, scientists shun as a serious topic of research, for the simple reason that if you look at the standard theories of physics, quantum mechanics and general relativity in particular, it would appear, simply looking at those theories, that there is no way to manipulate gravity. However, being a plotter, I guess is the right way to put it, I kept on plodding along and tried to find a way to do this sort of thing. And through a series of lucky accidents, seemed to have happened upon something that may work. It's not guaranteed yet, but I've got a gizmo sitting in a laboratory at the university. Indeed, I demonstrated it for a fellow from back east this past afternoon, which shows the behavior of the effects predicted by some theory that's been developed. Could you push the next slide, please? Okay. The reason why this is important as far as we generally are concerned is because if some means other than chemical propulsion and electric propulsion indeed even nuclear propulsion, is found, we're pretty much likely to be trapped in our gravity well of our planet. It may be that there are clever critters out there elsewhere in the cosmos. Indeed, they may be all over the place. But if it's physically impossible to traverse interstellar distances, then they're trapped in their gravity wells too, and all of the reports that you have of flying saucers and motherships and what have you is delusional, to be perfectly frank about it. For those of you who have had these experiences, and I've known some people who have had quite vivid experiences, they are disinclined to believe that that is likely. The other thing to assume is that since our solar system has been around roughly about a third of the age of the cosmos, about 14 billion years, our solar system being 4.5 billion years, okay, since it's been about a third of the age of the cosmos, there are stellar systems in other galaxies, indeed even in our galaxy, that are vastly older than is our stellar system. And if our stellar system is just an average sort of stellar system, and Earth-like planets are fairly common, as is now widely believed to be the case in scientific circles, then the likelihood that intelligent life has evolved elsewhere is pretty good. And there's a pretty high likelihood that if it is indeed possible to figure out how to traverse interstellar distances, and given the amount of time, thousands or millions or indeed even perhaps a few billion years longer than we have had to evolve, that someone or something has figured out how to do it. Okay? As far as we're concerned, what's on offer now, if you look at the more or less mainstream scientific media, next slide please, is something like this, so-called Generation Starship. I'm not going to show you pictures of UFOs, by the way, if that's what you're here for. Okay. That's an artist's rendition of a Generation Starship. The idea here, next slide, is that it would be nuclear powered and that it would achieve something along the order of 1/10 of the speed of light and travel to the nearest stellar system in some decades. That is to say, it would take longer than a human lifetime to make the transit, hence Generation Starship. You have several generations of people on the Starship living and dying before they get to their destination. Okay, next slide. What do we want to do? And of course, next slide. That's what we want to do. That's been on offer since the 1960s. Okay. I cribbed this slide from a friend's PowerPoint presentation given at JPL, God, going on 20 years ago now. He was giving a talk on pulse detonation rocket engines, and the last slide he put up without comment was this slide. Okay, next slide. What you're talking about there is what's now well known as an Alcubierre warp bubble, a warp drive, so-called. It's a system that was worked out basically. Miguel Alcubierre in 1994 wrote down the metric, so-called, that is to say, the equation of the bending of space-time that must be the case in order to achieve hyperfast travel across space. It turns out that the theory of relativity is right. And by the way, the theories, special and general relativity, are both right. You're not going to hear from me that some new miraculous theory is what we need to do this and all that. Okay? The theories of general relativity are right. And the loophole in general relativity, the simplest loophole, is to distort the space in such a way that you create a bubble in the space-time so that your ship sits inside the bubble. Next slide, please. And the bubble moves through space-time. You can make the bubble move at arbitrarily large velocities, much, much faster than the speed of light. Your spaceship is never going faster than the speed of light. it's going some small velocity or no velocity at all. Okay, next slide, please. The really neat way to get around space-time, of course, is not warp bubbles and all that, though that's now considered at the cutting edge and perhaps beyond the fringe. Okay, this is from a paper in 1988. That is to say, going on 30 years ago now. Okay, Kip Thorne and Michael Morris, Wormholes in Space-Time and Their Use for Interstellar Travel, a tool for teaching general relativity. They didn't fool anyone. They knew that they were semi-serious in talking about this as a realistic, a conceivably realistic possibility. Next slide, please. And there's the math. That's the math of what's called an absurdly benign wormhole. Okay? Next slide. A wormhole, as you know, probably from watching TV, if nothing else, or magazines or what have you, is a shortcut through a higher dimensional, hyperspatial so-called space-time, connecting via a very short throat to regions, this region here and this region here, via this tube, which is vastly exaggerated in length. This is supposed to be Alpha Centauri, if I recall correctly. Yes, 27 light years around this way and through this tube, some much shorter distance. Indeed, if you make a really good, absurdly benign wormhole, it'll look like the next slide, which is a cover from Scientific American, August 2002, sorry. That is an absurdly benign wormhole depiction coupling Times Square in North Africa. Okay? And you simply step through. The really weird thing about these things is that they are potentially time machines as well. That is to say, you can arrange things so that one of the wormhole mouths is located in the past or future of the other wormhole mouth, and simply by stepping through, traverse arbitrarily large distances in time. Stephen Hawking, when this all got started in 1992, came up with something he called the chronology protection conjecture, where he claimed that creating a wormhole and using smooth deformations of space-time, if you arranged the mouths of your wormhole in such a way that they created a time machine, one of the two mouths would have to traverse the future light cone of the other mouth, and that would create what is called a closed time-like curve, a CTC, or a closed time-like line, you sometimes said, CTL. And all you have to have is one measly photon on that path, and it just goes round and round and round instantaneously and blows it up. Okay? The only way you can time travel to the past is if you can find a way of literally ripping space-time so that you avoid the necessity of a smooth passage across the future light cone of one of the mouths of the wormhole. Next slide, please. Okay. We need a way to dispense with vast amounts of fuel. Rockets are not the way to the stars. They're probably not really the way to the outer solar system. They may be the way to Mars and the asteroids, and only at very, very great expense, blowing a lot of toxic crap into the air and ultimately into outer space and all that. Okay. Chemical rockets really are not the future of serious space-faring society or civilization, if you want. Hit it again. What's been going on in what I'll refer to as the advanced propulsion community, because there is a community. There are perhaps, a few dozen people worldwide who, like me, spend some of their time trying to figure out how to get around space-time quickly, and not with any more success than I've had, I'm happy to say at this point. Though I hope one of them succeeds. Either if they don't succeed, I hope I succeed. Anyway, one of the problems in doing this sort of thing is that there is a culture of doing science where human beings. We behave like human beings. And one of the best observations on human behavior is that the way people get started on this sort of a quest is they have a bright idea. They see what they think is a path forward, and they follow the path. And they keep on following it. The problem with following paths is that you have to be prepared to accept that you're wrong when you find out that you're wrong. Okay, that's probably a good life lesson in any event. But Frank Wilczek has this nice quote about the way in which people do science. You know, like Columbus, who found the new world while seeking a way to the old, explorers who make landfall on unexpected continents of ideas are often unprepared to accept what they have found. They keep seeking a way, keep seeking what they set to find. Okay, this is indeed one of the problems in this area. Okay, next hit, another quote. Could you press the button again, please? There. The thing to understand about this is that this is a normal part of progress forward. It's very easy if you are in the heat of debate and all that to get very cranked up about this and so on, and you look at the work of somebody else and you say, oh, that's wrong, and it may well be wrong, you know. But you need to understand, you need to have, how should I put it, a little empathy or compassion for the fact that if you don't make mistakes, you don't make progress. Because if you don't make mistakes, if you hit the button again, you'll get to see that that's Freeman Dyson. Okay? If you don't make mistakes, you won't be confident in what you have done being correct. Okay? If you don't know what's wrong, how can you be sure of what's right? Okay, next slide, please. Okay, is there any plausible physics for more realistic transport? That is to say, is there a way to make warp drives and wormholes, or at the very least, much less than making warp drives and wormholes, is there any way to do what is now trendily called in the field of advanced propulsion a space drive or a field propulsion technique? That is to say, the gravity manipulation that Steve laid on you at the beginning just before I started talking. That, by the way, is a plug for the book. Okay? For years, I went out of my way not to write a book. Okay? And a friend of mine who was manager of Millennium Projects for Lockheed Martin for a number of years, about 20 years ago, who is still a friend, kept after me and he said, you've got to write a book. No one will pay attention to you until you write a book. Okay? And finally, just to get him off my back, I got one of these sort of automatic email solicitations from Springer Verlag for a book proposal, and I figured, I can kill two birds with one stone. I can get Jim off my back, and I can test the theory that this is still not publishable in the reputable press. So I sent in a book proposal for what I was going to write. And to my amazement, they went ahead and said, oh, send us more. And I sent them more. They said, oh, we'll give you a contract. And then about a year later, this is a result of that. Should you be interested in purchasing it, this is the other plug, I would encourage you to purchase it through the Space Studies Institute website. They have it cheap on their website, and then they get the profit as well as the royalties. The royalties from the book are assigned to the Space Studies Institute Exotic Propulsion Initiative, as they call it. Okay, another hit of the button, please. Oh, no, back. Yeah, leave it there. Okay, wormholes and warp drives, maybe. Quantum zero-point fields, the quantum vacuum, that's the fashionable view. the most common view you'll find in the advanced propulsion community stems, as far as I can tell, from the idea that gravity control is weird and quantum mechanics is weird, therefore they must be related. Okay? Which isn't necessarily true at all. Okay? But that is the popular way within the field of advanced propulsion of looking at this stuff. The last little thing down here, Mach effects, is the stuff that I do. It's the insight that I had back in the fall of 1989 and then struggled with for a number of years until I got it all sorted out and all that, and may actually turn out to work. Next slide, please. Okay. These are PowerPoints, by the way, for a talk that I gave at a technical conference. Some of them are PowerPoints for the technical conference that I gave a talk at last fall. So bear with me. Some of them I'm going to go through pretty fast. Okay. The way in which physics and advanced propulsion and all of that stuff works out is mainstream physics is that purple circle, and within mainstream physics there are two overlapping camps. There are people who are quantum mechanics. These are people who do something called relativistic quantum field theory. And there are general relativists. And of course, general relativists know relativistic quantum field theory and vice versa. But their first love is either relativistic quantum field theory or general relativity. Okay? Real general relativists are ones who are acculturated within the community of general relativists. Okay? Subsets of those who are interested in advanced propulsion, I've indicated here as zero pointers. These are people who are convinced that the quantum vacuum is a repository of vast amounts of energy that is just lying there waiting to be tapped, and all we have to do is figure out how to unlock the quantum vacuum. Okay? The vacuum, by the way, is empty. It is a vast repository of energy, but it's not electromagnetic or the other forces of nature. It's gravitational energy. Because over here, Einstein and Mach, what you find is the vacuum of space-time is the gravitational field of the matter in the universe. And it turns out that that gravitational field is enormously strong. The only reason why you don't detect it, actually you do detect it. Every time you push on something, the reason why it pushes back is because of the energy in the gravitational field that you're pushing on the object with. Okay? Okay, so you have these, and when you get down below this line here, this is a path that's being followed by a NASA engineer and physicist named Sonny White at NASA Johnson. Over here, you have the Arnowit, Deser, and Misner model of electrons, and Einstein and Mach, which suggests that there may be a way, if you can find a way to screen normal matter from the gravitational influence of distant matter in the universe, of exposing something called its bare mass. And the bare mass is negative, and it's utterly humongous. Next slide, please. Okay. We're going to switch up for a moment and talk about something that you may have heard about. About a year ago, a friend of mine who works with Sonny White at NASA Johnson started blogging on a non-NASA website called NASA Spaceflight and talking about his work with something called the EM drive over here, originally invented by Roger Scheuer, a British electrical engineer, back around 2002. Scheuer's been fooling around with those things for 20 years, going on 20 years now. Next hit. Okay, we need to find a way of producing propulsion without great gooey gobs of stuff blowing out of a tailpipe. Next. Machinery must be made available on techniques that are available to us now. Electromagnetic equipment. Next. How can electromagnetism be used to produce thrust? Next. Resonant cavities is Scheuer's answer. Okay, next slide. There's a Scheuer EM drive. This, believe it or not, was on a Science Channel show, as you can tell from the logo from which I boosted this. This is, of course, under fair use doctrine, by the way. Okay, this is from something that was on actually George Lucas, I think it was. It was a celebratory show about George Lucas. At the end of the show, he said, "Oh, we're on the verge of..." Don't worry about it. Leave it. Next slide. Okay. All right. Next hit. The thing that Scheuer found initially, and Sonny and Paul at NASA Johnson found, was that these EM drives, so-called, only work when there is a plastic disc mounted inside the resonant cavity. Okay, next slide. In case you want to see what these guys look like, that's Sonny White, that's Paul March, and this guy over here is a guy who took the heat for something called the Breakthrough Propulsion Physics Project. A fellow at NASA, Marshall, who was the godfather of Mark Millis's project at NASA Glenn. Next slide, please. How does this work? Standard mainstream physics, it doesn't work. As a matter of fact, you can, if you go online and look up EM drives, you'll find that John Baez and Sean Carroll have derided this publicly and so on. Next hit. It's a quantum vacuum plasma thruster, is what Sonny and Paul, at least a year or so ago, were claiming. Okay, next. Quantum vacuum plasma thruster was the main emphasis of the talk that I gave last fall. Mach effects actually may have an explanation for the thrust if there is some real thrust in these things, but that's not absolutely certain yet. Next slide. Quantum vacuum plasma hit is nonsense in the view of mainstream quantum mechanics. There is no quantum vacuum plasma. The plasma that they want is a plasma of electron-positron pairs, and the energy required to create a pair of electrons and positrons, electron and positron, is twice the energy of the electron, which is a non-negligible amount of energy. Next hit. According to Hal Puthoff and Sonny White, electron-positron pairs. Okay. According to White, he was at least a year ago claiming that these things are densified in the presence of matter by the presence of an externally applied electromagnetic field. Okay. They violate energy and momentum conservation, and so they can only exist for a very brief amount of time. How long does a pair live? 10 to the minus 22 seconds, which is a very, 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 very short period of time. Next slide. How many pairs do you need to produce the observed thrust? Tens of micronewtons are the thrusts. Great gooey gobs of them. Okay? And what I'm going to go through, next slide before a digression. We're going to skip through this real quickly. Okay, read the book. Next slide. That's Ernst Mach, by the way. That's from the non-technical talk that I gave a few years ago. He's the guy who started all this. He's the one who said, hey, look, when you spin and your arms fly up, it's because you're spinning with respect to what he called the fixed stars, that is to say, the distant matter in the cosmos. How can that be? Einstein's answer was the gravitational field couples them, and that's what does it. Next slide. The guy who picked up on Einstein and Mach's idea in the early 50s is this guy, Dennis Sciama. Cambridge University for many years, and then the Institute for Theoretical Physics in Trieste. Next slide. We're going to go through this one real quickly, because I'm sure you're not interested in the technical details of this stuff. Next slide. That's the equation, by the way, that underlies Mach effects. The term in green here is the one that we're looking at now. That is sufficiently large so that you can see its effects in laboratory experiments. And these have been scrubbed and done very carefully with multiple copies. Devices have been sent to other labs. They've seen the same stuff, and so on. This term here is a term that must have some purchase on reality if it turns out that we're going to make wormholes and warp drives. Next slide. Okay. That's a MET. It's a stack of PZT crystals with an aluminum cap and a brass reaction mass. The PZT crystals are glued together this way. That's what one of these things looks like. Indeed, a device of this sort here was what was running this afternoon. Okay, next slide. Next slide. Oh, you want to read the caption? Okay. Okay, next slide, please. All right, that's it going in on the thrust balance. The thrust balance is this aluminum beam here. This thing flips over into a Faraday cage. It's mounted on the end of the balance. And one of the way of removing spurious signals is to reverse the direction of the device to make sure that the thrust reverses when you change the direction. It's one of the basic tests, and it turns out it does. Okay, next slide. The thrust balance schematically looks like this. Flexural bearings supporting that beam, the thruster over here, counterweights over here, and you measure the position of the beam. The flexural bearings give you a little bit of spring so that the thrust pushes against the spring. Next slide. That's the thrust balance. Next slide. That's in its vacuum chamber. And of course I have to mention Croc, okay, the mascot of our experiment. Okay, next slide. Okay, press the button. Press the forward button. There we go. That's how these work. You make the mass of the stack fluctuate and at the same time push and pull on the stack as it's fluctuating in synchrony so that you're pushing when it's heavy and pulling when it's light and so on. And that's the way you can make these things be so-called propellantless thrusters. Next slide.
Create a harmonic force? Is that a harmonic force? In other words, does the force grow over time? Or
Oh yeah, no, the force stays, as long as the power level input is maintained, the force stays the same, but the acceleration increases.
There you go.
Yes.
Yep.
Yeah, it's not an inchworm type of operation. It produces a force, which time averages, has a non-zero time average, and causes an acceleration. In principle, if you can get all of the technical details right, and that's a big if, these should be possible to use for heavy lift operations. But that's some years down the line, I would guess, even if everything works out perfectly. This is some data. This is with the device pointing in one direction. That's with it pointing in the other direction. As you can see, the wiggly lines here are inverted here. And if you hit the next slide, that's the difference between the two. You can see that when the device is turned on here, there's a switching transient, goes up here, another switching transient, and so on. The reason why it's switching transients, there are two reasons. One is because switching transients are the way in which these things will ultimately be developed. And indeed, the SSI now has an assigned patent that was just issued on switching transients and parametric amplification for thrusters of this sort. Okay, so that's part of the reason. But the real reason why the lines are like that is because when you have people come into your lab, they want to see big swings out of the noise. They don't want to see something where you have to take 100 pictures and then average them in order to elicit a small bump. Next slide. Okay, that's forward and reverse. Again, another slide. Back to the main message. How do you weigh the great gooey gobs of electron-positron pairs? Okay, slide. It turns out that I've been at this for a very, very long time. Okay, and I've built an awful lot of stuff. And we just happened to have, sitting around in the lab, some equipment which made it possible to test whether or not the quantum vacuum plasma hypothesis was true. It isn't, by the way. Next slide. We'll go through this quickly. This is the weigh sensor that's used in that experiment. It's a Unimeasure U80. They don't sell them anymore. That's the shielding for the U80. Next slide. That's it with the partially reassembled vacuum chamber. That's with the fully reassembled vacuum chamber. When you're measuring very small weights or thrust, you have to connect power to the device that you're running. And the way to do that, which is becoming standard in this business now, is to use liquid metal contacts, gallon stand, okay, there with copper wires poking down into the fluid. That way you don't induce forces and torques and stuff like that, which a bundle of wires would produce. Next slide. This is one of the check protocols for the weigh measurement. You just stick some blocks under the weigh stage so that the thing is fixed, and then you run it as if it were being run normally, and then you subtract the result that you get. Next slide. Okay, from what you got with it running free. Next slide. Okay. Next slide. And what you see here finally is that there's a switching transient here, but there's nothing there. And that's at a sufficiently high level of accuracy to show that any reasonable density of electron-positron pairs being so-called densified in the polyethylene disks in their EM drives or in the device that we were running is simply not there. Okay, so the quantum vacuum plasma is a dead duck. Next slide. Okay, does failure of the quantum vacuum plasma conjecture mean that it's not yet space drive time? No, MET's work, that is to say Mach Effect Thruster's work. Okay. And the experiment done with EM drives seemed to show that it is indeed possible to produce thrust without traditional propellant. The plastic discs in these things, and I've looked at Paul's data very carefully, and I've given him a hard time about various aspects of it and so on, but it appears that there may be a real signal in there. You know, so, next slide. This is the main message. The main message is that if you're going to try and do the physics of advanced propulsion, you simply have to understand gravity. And the way you have to understand gravity is the way in which Einstein understood it, not the way in which most physicists nowadays understand it. Most physicists do not think that inertia is a gravitational phenomenon, whereas in fact in general relativity it is. This is something that there's arguments about. People have written papers about this. People have made mistakes and all that. My colleague Heidi Fern, who was on the title page of this talk, with whom I've been working for the past 4 or 5 years now, has worked out, she's a theoretician. As you can tell, I'm a cantankerous old experimentalist. Okay? She's worked out the theory of something called Hoyle-Narlikar advanced waves. It's a theory of gravity that goes a step beyond general relativity, where general relativity is a subset of this broader theory that Hoyle and Narlikar created back in the 1960s. The reason why Hoyle and Narlikar's theory didn't go anywhere in the 60s was because Stephen Hawking came along and pointed out that as it was presented then, it had a fundamental flaw. It had the flaw that the way advanced wave physics works is the reason why things are instantaneous is because when you wiggle something here, waves go propagating out into the future, and out in the future they make stuff out there wiggle, and the stuff out there wiggling in the future sends waves backwards in time to the thing here that's wiggling, and it's the action of those waves coming backward in time that produces the inertial reaction force. Okay? This is chapter 2 of the book. Okay? And you will find it very weird and hardly believable. As a matter of fact, in a way it's weirder, I suppose, than ghosts and poltergeists and things like that. Certainly a lot less common. But it's very likely the way reality actually is. Okay? It's very likely that the world in which we exist is not the world of our commonplace experience, but rather a timeless, so-called, as philosophers of science like to call it, block universe. Okay? A friend of mine, John Kramer, has invented an interpretation of quantum mechanics, and he just published a book on this with Springer, who came out in January, as a matter of fact, called The Transactional Interpretation of Quantum Mechanics. And I recommend that to you too. It's an outstanding book. It's just first rate. I ran across John's work back in the early 90s and so on. And we've been friends for a long time. And I knew then that inertia had this property, and I looked at John's work and I said, ah, yes, that makes sense. When I read Feynman's Nobel Prize address back in 1965, Feynman was one of the originators of this so-called interaction, advanced and retarded interaction, so-called absorber theory of electrodynamics, not gravity. And he devoted half of his address to that. And I read it in the mid-1960s, and I thought, this guy's nuts. That's just preposterous. Time obviously marches on. Here we are. Time is marching on. How can it be that reality is something other than just time marching on? A evanescent present with a yet-to-be future and a long-gone past. And it turns out that's not the way the world really is. Physics says it's much weirder than that. Okay. Anyway, the bottom line on this is gravity is the way to the future, if there is any way to that future. Next slide. But we need to keep perspective on what we're doing here. Next slide. 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 One more slide. Okay. You need to understand that what we're talking about here tonight is at the intersection of serious science, because I have done this project to the best of my ability as serious science. Because nobody's going to get to the stars on wishful thinking. Nobody's going to get to the stars on their favorite unified field theory. Nobody's going to get to the stars trying to figure out how to hum the right frequency or anything like that. If it's going to be done, it's going to be done with basic, solid, sound, reasonable, experimentally replicable physics. You know, and that's what I've tried to do. I've made a little progress, and do buy the book, please, from the SSI. Support the Exotic Propulsion Initiative. That operation and Mark Millis's Tau Zero Foundation back east are, to my knowledge, the only operations in the United States that are supporting serious work on advanced propulsion. And it's a worthy cause to donate your money to. They're 501c3s, so you get a tax deduction. Okay, any questions?
Very, very interesting. It's the first time that I've actually heard someone apply science to the field that we look at in this way. So I applaud you, and I appreciate it. I have an engineering background myself, so I like that. Oftentimes, and even going back to Area 51, Bob Lazar, he described a propulsion system. Now, this is all, allegedly. Something to do with spinning mercury in a toroidal thing. Do you know anything about that? Have you ever looked at that? And would you like to make a comment?
Sort of.
Sort of.
You should, yeah. I'm writing a sequel along with a couple of other people to making starships, and I'm going to have some stuff in there on that, an overview of what's been going on from the perspective of someone working in the science end of this stuff. What it boils down to is that given the wild popularity of the flying saucer UFO phenomenon, what is it, the statistic is 50% of the people in the world, or at least in the United States, take seriously the idea that... Yep. Yeah, I know, and that's on pretty flimsy evidence, to be perfectly frank. Scientifically speaking, it's pretty flimsy evidence, notwithstanding my friends who claim to have seen stuff.
Until you've seen one, and then it's 100%.
Yeah, let me tell you what the problem with it is. The problem with it is simple. It's what's called cargo cult science. Okay, the name derives from a phenomenon that was observed by anthropologists in the Polynesian Islands after World War II.
Sure.
World War II DC-3s flew in supplies and supplies and supplies for military forces who were passing through, and the Aboriginal population saw these things come in from the sky and disgorge all this stuff and all that, and goodies. And so when the planes and the military went away, they started creating bamboo or whatever planes, hoping that would cause the DC-3s to come back and disgorge all of the goodies. That's cargo cult. Okay. The UFO phenomenon from a scientist's perspective, or at least from my perspective, I won't tag all scientists with this, from my perspective, is very much like cargo cults science. The reports that you get of so-called flying saucer incidents, it's commonplace that they involve electromagnetic phenomena. That's like saying, cheese involves milk.
Yeah.
It doesn't tell you anything really interesting. The type of information that I've seen, and I haven't looked at this stuff carefully in years. I looked at it with some care 40 or 50 years ago, and I occasionally take the pulse and see what's going on. But as far as I can tell, nothing much has improved since 40 or 50 years ago, and at that time there were only 1 or 2 sightings that involved any instrumentation more sophisticated than a car conking out or lights flashing or what have you, okay, which tells you nothing, basically, from the scientific book.
A lot of data has come from there to here, yeah. There's quite a bit out there if you look into it. But anyway, go on.
Yes. But it doesn't tell you how to control gravity.
No, absolutely not. Absolutely not.
That's the point.
No.
If it doesn't tell you how to control gravity, it's useless.
It's useless, I agree.
Yes.
All you can do is observe and report the phenomenon.
But
I'm sorry, go ahead.
Yeah. The problem is that observing the phenomenon and reporting what you see, if you report what you see and it is not of useful value in figuring out how to solve the problem of so-called gravity control, then it's in effect useless. It's an interesting tale. It's nice to have meetings, talk about it and all that.
Right.
But from my perspective, it's of no interest because it doesn't tell me anything that will help me figure out how to do what you really actually want to do, which is manipulate gravitational interactions.
Yeah, true. Which would, of course, I meant to ask you something about your device.
Yeah.
You know, great gobs of these 10 to the minus 20 or whatever.
2 seconds.
Yeah.
Electron
particles.
They aren't there.
They don't exist, basically,
No,
you know.
they don't.
So, and then to get great gobs of them means that, to me, would imply tons of energy to produce those things, or at least prolonged energy over a long, long period of time, or spiked energy, high energy.
It's supposed to be a quantum vacuum fluctuation, that when you apply a low energy electromagnetic field to certain substances, that it induces the presence of these things.
The quantum vacuum.
Very large
numbers. Where the energy is.
But it's still a fluctuation.
Where the energy is stored.
Basically, the idea is that it's an unstable situation, and if you just trip it a little bit, boom, you get a lot more than you put in.
Interesting. Okay. So there's sort of like the zero-point energy idea.
It is a zero-point energy idea.
Yeah. Interesting.
Yes.
Now, going back to what you were saying before, you may not, if you knew the ingredients of a cake, for example, or if you could taste the ingredients of the cake, you wouldn't know how it's made, but you'd know that there might exist cardamom and definitely not bitters. Something like that. So, for example, when someone observes an object or has an experience, one common thing besides electromagnetic energy, things like batteries discharging and things turning off, one common thing reported time and time again is a lack of sound. We call this the Oz effect. A lack of sound, a lack of almost a feeling of no passage of time, and oftentimes, in fact, the experiencer will have in his envelope, let's say, the passage of an hour, and then when he comes back out of this situation, only a few minutes have passed. So you can't really say anything about that in terms of how it's going to help you make a propulsion system, but you might say, well, definitely it's, or you might not say definitely, but you say, well, possibly this, whatever this field is, it is influencing time, so we know that it's a time-space type propulsion system, or we can conjecture that it's a time-space propulsion system.
Gravity is space-time, and Einstein's
So if you're influencing it, you're creating a time machine.
If you're manipulating it, you are causing it to change in some way.
Right.
Okay.
So these things, if they exist, that we see, and they are moving using this sort of propulsion, we might say that they're not just, they're time machines, basically.
I
mean, not in a H.G. Wells sense of the word, but in.
Yeah, you're going to have to read the sequel when I get it written. No, time machines. Let me put it this way: the fundamental thing to understand about this is that space-time is gravity. It is not something else.
Is gravity an expression of space-time, or is space-time
it is. Space-time is the gravitational field.
Okay.
Okay, that's what Einstein said.
Okay.
That's what he called Mach's principle in 1918, and then he got dumped on by Willem de Sitter and a bunch of other people and all that, and there was a big debate, and he gave a lecture at Leiden on taking up a honorary chair position in 1920 and talked about the ether and got people in the zero-point field all cranked up because, oh, the ether, the zero-point field, and so on. And what he meant was space-time is the gravitational field. It is not something else. Gravity is not something in space-time. It is space-time. So when you manipulate gravity, you are manipulating space-time. That's why when you make a wormhole, when you get a Jupiter mass of negative rest mass matter in a sphere, say 10 meters in diameter or thereabouts, you can create a wormhole. Okay? The problem is, where do you get a Jupiter mass of negative rest mass matter? And the answer to that question, if you read chapters 7, 8, and 9, is it's all around us. indeed contain within you an utterly enormous amount of negative rest mass matter. It's the bare mass of all of the elementary particles that make you up. The only reason why it isn't exposed is because of the gravitational action of everything else in the universe on you. And if you can find a way to screen that interaction, you reveal the bare mass. And now you've got your Jupiter mass of negative rest mass matter. Okay?
Interesting.
And that's a real tall order. But if the experiences that you and your compatriots are having and all that are true, it means that someone is, or something, has figured out how to do this. Okay? But within the physics that is we know today, that's, as far as I can see, the only hope of making either warp drives or wormholes. Okay?
Beautiful. Beautiful. Okay, that was a good answer, guys. Who's next? All right, Stephen Kaiser.
Thank you. Did you find Bob Lazar credible? What you've known about him?
No.
Not at all.
No. Let me tell you a story.
Please.
A little bit of history that you'd not find much of anywhere. Back in the 1990s was the heyday of Lazar and Area 51 and all that. And Lazar went around talking about some papoose lake or something like that, and saucers and stuff like that.
As far as yeah.
Yeah, okay. In 1997, I was plugging away in my lab, doing what I was doing, whatever it was at that time on this project. And a fellow who was a member of a group that called themselves the Groom Lake Interceptors showed up in the physics department. Got a master's program going at about that time.
This is at Cal State Fullerton?
At Cal State Fullerton. His name is Tom Mahood. He has a website called theotherhand.org. So you can look it up and he'll tell you in colorful language about his experiences with this and all that, if you're interested. The Groom Lake Interceptors was a group of people, I won't try to call up the names of all of them. There are 4 or 5 of them. And they set out to debunk what they regarded as the extreme and overwrought claims and stuff that was clearly incredible. And Tom was the one who got assigned Lazar's case. And he went and dug and dug and dug and dug and all that. And what he discovered was that there were vast inconsistencies in the story. That the likelihood that what Lazar was claiming was correct was essentially nil. And from the physics point of view, all you have to do is look at the claims that he was making as physics, and it's obvious nonsense. Element 115 or 117, that sort of stuff, doesn't have anything to do with us. You know, it's irrelevant. You know, gravity control is not going to be created by making supermassive nuclei.
Your own interest in this, was it inspired by seeing UFOs or talking with other people?
Have I ever seen a flying saucer? No, I have never seen a flying saucer.
Do you think that they exist?
I'm going to claim agnosticism on that.
I can understand that.
I have enough friends and people who I know whose judgment and credibility I trust to believe that they think they have seen something that actually operates in the way that these stories claim that they do. So I'm not willing to just dismiss it out of hand, especially in light of the fact that if life is common in the universe and stellar systems have been around millions or billions of years longer than ours, you know, that those clever critters couldn't figure out how to do it, you know, and we might. I find that even more preposterous.
What motivated your interest in gravity drives?
As I said, forbidden planet. if it can be done, why not? It set the seed. It said, well, hell, we know about gravity and we know about electromagnetism and all that. I hadn't even taken high school physics at the time. So what did I know? But everybody was going around. TVs were new and stuff like that, cars, and they were talking about flying cars. And Life magazine was putting big photo plays of flying saucers and stuff like that, so on. I thought, well, maybe, maybe not. But you're never going to invent something unless you try. And that was in the back. I pursued a different path as a professional career, but the underlying thread in that career was to eventually writing the book that I wrote, and now the sequel that I'm in the process of writing.
None of this information about UFOs out there seemed to be credible to you. I mean, millions of witnesses and people that experienced that.
As I say, I read, the only time that I really read that literature at all seriously was in the late 60s and early 70s, when the AAAS, the Condon report came out, and the AAAS had a meeting sponsored by Thornton Page and Carl Sagan on UFOs and SETI and stuff like that, And I actually read the Condon report, and I read Condon's statement, and it said, oh, it's a bunch of baloney and so on. And then you read some of the reports in the back of the thing, and you say, he obviously didn't read the report that he's writing about, because the people who wrote the reports in the back of the thing said, hey, gee, this isn't quite as obvious as it. So, my view on this has always been that you should not spend a lot of time on stuff that isn't helpful. Okay? That you should try to stay focused on what potentially is helpful. And as I say, at that time, nothing that I saw in the literature struck me as particularly helpful.
What could be more impelling than being in contact with other living beings in our universe? Do you think that out at Area 51 that there's anything unusual happening at S4 or Groom Lake or at Dulce or some of these other places? That's the reverse engineer story. Lazar being the most obvious example. The most public, yeah.
The most public example, yes. Yeah, no, I had a run-in with that through a fellow named Gordon Novell about 5-6 years ago. And Novell approached me and wanted me to help him out with what he was working on. And I did a little checking and all that. He said that he had been authorized to have access to reverse engineers who would spill the beans to him. Okay? And I said, gee, Gordon, if you get reverse engineers to spill the beans to you and you tell me what the beans are and they make sense, then we'll talk. He never came along with any beans.
You don't think the government is hoarding the beans somewhere? I mean,
is there a vast conspiracy of the X-Files sort? Probably not. As a friend of mine in government, as I say, I've had glancing blows with the government for many, many years in this business. As a friend of mine in government back in the 80s said, the government is a really, really, really big place. And even the NSA can't keep track of all of them. Okay? So somewhere out there in the apparatus, there may be some little group of people who think they're masters of the universe or something like that. I can't tell you that isn't the case with absolute certainty. But I think it's exceedingly unlikely, and that it's genuine, I would say, essentially impossible. Yes?
Hi. Okay. One of the most popular theories for people into UFOs is that aliens are evolved humans and they've found a way to come back in time and observe themselves. I don't want to talk about aliens. I think we've talked enough about that for your limit.
Yes.
But I want to ask you to elaborate a little bit on ripping space-time. I know you said it's much less feasible than traveling in the future, but theoretically, could there possibly be a way?
Time travel to the past.
To the
is what
past,
you want
yeah.
to know.
Yeah.
Time travel to the past, my guess is, and it's a guess, it's not a certainty, my guess is that Stephen Hawking's argument, contrary to what Kip Thorne would have had be the case back in 1994, when he did the quantum field theoretic calculation for his chronology protection conjecture, he said we're going to need quantum gravity to solve this. But he thought that it might turn out that Hawking's mechanism wouldn't work. The way this works is that wormholes have a defocusing effect. The mouths of wormholes are flared in such a way that they have a defocusing effect. So when you get a closed time-like line on each recirculation, there's non-negligible probability that the photon will be diverted off the exact path.
Is that why they say that if you travel back in time, you could never travel back to the future and have the same future that you came from? Would that change? Is that possible to go back and
time travel? Everybody wants to know about time travel. No, what it means is if you can travel to the past, and my guess is that even though Hawking's argument may be right, that it may indeed prove possible to tear space-time and avoid Hawking's chronology protection conjecture. So I do not rule out the possibility of time travel to the past. I think it's unlikely, but there's an outside chance that it may be possible. Okay?
Thank you.
What I do say, following on that, is that if time travel to the past is possible, it means that you've already out there in the future done it. And so the present that you are experiencing now is a present that exists because of what you do in the future. Okay? And that's a head bender, I grant you, but that's the logic of the situation. Yes?
There have been many recordings on radar of the speeds at which these objects are moving. And what's always struck me is that there seems to be no sound, no sonic boom, even though they're moving at multiples of the speed of sound, which suggests that that might give a clue as to what the propulsion mechanism is, if the word propulsion is even applicable.
No. It actually doesn't have anything to do with it.
No.
What it means is that the space-time is being distorted in such a way that the airflow is lamellar.
The airflow is
Lamellar. It's smooth airflow. Okay? So you're not creating a sonic boom. And soundlessness is hardly surprising either, because if these things are electromagnetically operated at the frequencies that look realistic to operate them at, they're not in the sonic region. They're up in the gigahertz range, and you wouldn't hear anything. So neither of those things turn out to be particularly interesting. The implications of those things for how much such a system must work are, how should I put it, commonplace, I think is the way I would put it. It's not helpful. It doesn't tell you how to do the nuts and bolts of manipulating the space-time in the way in which you have to in order to achieve what you want to do.
Yeah, I've always been captivated by the reports that say before moving UFOs will do, before or after they do a certain type of maneuver, they will they will divide themselves into a whole bunch of pieces, or coalesce back. Is that something that gives you any kind of clue, or?
Show-offs.
What do you mean?
Show-offs. They're putting on a rocket show for you. Fireworks show.
Are you serious?
I'm serious.
Oh.
You don't have to You know, if you're flying along in your flying saucer, you don't need to bust it up into a bunch of pieces and then put it back together. That's just showing off. If it's a genuine observation.
And why might they want to just ego? That begs another question.
I am not practiced in alien psychology, so I have no answer for you.
Well, that's an interesting answer, though. They're showing off. Okay, thank you.
Well, let's put it this way. If you were doing it or I were doing it, I would call it showing off.
So, you seem very practical. As far as being able to get to Mars the quickest possible, let's say in the next 20 years, what kind of rocket engines of what kind do you predict? Like to say get there in 30 days.
With a real heavy-duty nuclear rocket, you can get there in 30 days, probably. Is that the way it'll be done? I doubt it. You know, the issues with nuclear energy are sufficiently daunting that it's unlikely, in my opinion, that that's the way that NASA will go if we continue along the rocket path. You know, the real question is there enough evidence now to suggest that there's an alternative way of doing this? Mm-hmm. Okay, and I would argue that perhaps we're approaching the tipping point of enough evidence of that sort being available to make it worth trying to seriously find out. Okay. Right. Okay. So far, the effort has not been serious, as far as I can tell. You know, other than on the part of individuals like me.
Okay. Thank you.
Sorry, I gotta go. But you said something in your talk that intrigued me, and I just want to be clear that I heard it right. I thought I heard you say that in the present time, that matter creates patterns or effects in space-time continuum, going forwards and backwards. Did I hear that right?
If you accelerate matter, it produces a, quotes, kink in the gravitational field, and since space-time is the gravitational field, you're producing a kink. When you accelerate, when you do this, you're producing a little kink in space-time that goes propagating out at the speed of light, and it interacts with the stuff out there, which wiggles and sends little wavelets back here.
So we're constantly affecting the past continuum and the present? No.
That's why you need to read John Kramer's book. Because when you wiggle something here and the kinks go out to the future and the stuff out there wiggles and sends the kinks back to the past, all of those things coming back to the past get to you right at the instant when you do this, and they cancel out all the waves that otherwise would go into the past.
Okay, so that's a canceling effect. And then the general question I had is that, you know, we all know that the Manhattan Project and things like that were secret projects. And you don't seem to acknowledge the possibility of any sort of secret projects at all.
Oh, there are secret projects.
Does that
make
sense that there might be?
There are secret projects. But what I will say about those secret projects is that they are probably all misguided.
Okay.
You know, or a large number of them are misguided.
Don't you think that there's weapons that it might be secret that are beyond the public domain?
Oh, I'm sure the military has secret weapons. And I'm sure, you know, and I'm sure that the intelligence agencies run what I call an early warning system. They have people out in the communities like this and various areas, just in case somebody has a bright idea that turns out to pan out. Okay? The problem is that by the time people figure out that the bright idea is actually a bright idea, the chances are you can't put the genie back in the bottle.
Got it.
Okay? That it's out there. And the best you can do at that point is to try and hide it in plain sight.
Okay.
Okay? By garbaging it up with a lot of other stuff and all that, and hope that they can't figure out, your competitors can't figure out the wheat from the chaff.
Got it. Thank you.
Good evening. I have a quick question regarding gravity and space-time, as you were discussing it earlier. I'm curious, you're saying that gravity is space-time. So is it okay to assume that what we're experiencing as space and time on Earth is a product of the gravitation of Earth and the solar system?
No, it's a product of the gravitation of the universe predominantly.
So our experience of it wouldn't
Let-
necessarily change if we moved to a different spot in the universe.
Let me put it this way. The inertial forces that you feel here on Earth are imperceptibly different from the inertial forces you feel in deep outer space when you're sitting in a rocket accelerating at 1g. Okay? This is what Einstein called the equivalence principle. What he said the reason for that is that in the rocket in deep outer space accelerating at 1g, a gravity-like field appears which acts upon you in the rocket, pushing you down on the floor of the rocket as it accelerates. Okay? And then he figured out later on, it isn't just a gravity-like field, it is the gravitational field of the distant matter in the universe. This is what he called Mach's principle. Okay?
So we're experiencing everything at the same time all the time.
It turns out, for theoretical reasons of subtlety that I prefer not to go into, that the locally measured invariant of gravitation turns out to be the square of the speed of light. That means that something called the scalar gravitational potential, the one number that you assigned to gravity at every point in space-time, when measured locally, is exactly equal to the square of the speed of light. Okay? And I note also that the only other locally measured invariant in relativity theory is the vacuum speed of light. And it turns out dimensionally to be correct too. A gravitational potential is a velocity squared in dimensions. Okay? So gravity and inertia are inextricably interlinked. You know, what Einstein saw was that in Newton's system, he says, when you push on something, the space-time causes it to push back, but in pushing back on the thing to give you the inertial reaction force, there is no action of the object on the space-time itself. General relativity says the object itself affects the space-time in addition to being pushed back on by the space-time. The underlying reality of realities is the gravitational field. Okay? And all of the other stuff is less complicated stuff that pops up in so-called locally gauge invariant relativistic quantum field theories. Okay? Which is us and all the stuff you see around us and all that. Okay? But it all plays itself out in space-time, which is gravity.
All right. Thank you.
Going further with that question, then, is inertia a characteristic of matter, or is it a measure of gravity on matter?
Repeat that question.
Is inertia a characteristic of matter inherent in matter, or is it simply a causality of gravity on matter?
It's both.
Okay.
I'm sorry, it's both.
No, it's okay.
You're trying to do what everybody tries to do in this. Since Einstein invented general relativity, there have been a long string of physicists who have come along and tried to reinterpret general relativity as a locally gauge invariant relativistic quantum field theory. It's called quantum gravity, and you have been hearing for decades now, nobody's figured out quantum gravity. The reason why they haven't figured out quantum gravity may well be because there isn't any quantum gravity. Because gravity is the thing in which quantum mechanics exists. Okay? and is not itself quantizable. Okay? But the program of theoretical physics for the last century, for the most part, has been trying to figure out how to quantize gravity. As a matter of fact, my colleague Heidi Fern said to me this afternoon, I asked her to write up something that she had done on this paper where she had shown that Hawking's critique of Hoyle-Narlikar's theory is solved by the accelerating universe. Okay, I said to her, you know, you need to write this up for this e-book we're doing, and she said, but no quantum gravity, because I had said that to her earlier. And I said, no, if you stumble on quantum gravity, it's okay. Okay, now, it's not the right question. You're asking the wrong question.
I'm just trying to understand.
Reality is both the space-time and the stuff that's in it. Okay? And you can't have one without the other. That's really what it boils down to. And that, I understand that that's not easy to get your head around, but that...
Well, for me, in my simplistic mind, I'm thinking of gravity now more as a field than an effect. You know what I mean?
Well,
like that matter exists within this thing. That's space-time gravity, no?
Matter, Einstein believed, would likely turn out to be what John Wheeler tried to invent back around 1960, something which he called geons, toruses of wrapped up and knotted space-time.
So in other words, space-time coming together in some sort of a toroid knot creates matter.
That was Wheeler's idea. It didn't work out then. It was
but it seems to be what you're implying.
I'm an experimentalist.
Okay.
I'm not going to go there. Sorry about that.
All right, we have a question.
Okay, one last thing is there a mass limit of spacecraft going in and out of hyperspace and stuff, you know? And the thing about hyperspace, you know, they have all this stuff in Star Wars. Is there a mass limit, you know, like can really very large spacecraft go in and out of hyperspace like the Death Star or the Dark Star out of Star Wars and stuff? Is there a limit on the masses of ships that go in and out of hyperspace?
The simple, honest answer is I don't know. Okay. Sorry about that.
All right, do we have any more questions, guys? One quick one.
Have you ever, there are people, physicists, that talk about the nature of spin. And spin does something to the fabric of time-space that potentializes it and maybe can be used in, huge leaps of distance.
Dennis Sciama and a fellow named Kibble back in the 1960s tried to incorporate spin in a general relativistic framework using something called torsion, and it didn't work. So the answer is spin is an interesting problem, an interesting feature of theoretical physics, but is it fundamental in the sense that it's going to have a major impact on the stuff that I've been talking about? My guess is probably not.
Are you familiar with the Soviet thermionic engines?
No.
Have you ever heard of them before?
I've heard of thermionic engines, yes, but
no. Thermionic. The nuclear-powered
nuclear-powered, yeah.
Rockets.
Nuclear rockets, yes. The extreme version being the Orion project, sponsored by Freeman Dyson back around 1960. Dropping nukes out of the back of your spaceship and detonating them to ablate stuff off of a shield on the end of the craft.
Well, I don't think it's exactly that. I think they have one at Kirkland Air Force Base in Albuquerque.
Oh, you're talking about NERVA. Yeah, no. Nuclear rockets are not a good idea because they are highly toxic.
Right, but that's what you're proposing that'll get us to Mars in a month.
Yes, I know, and I said that's why NASA probably
won't
build it. Yes.
Let's hope they don't.
Yes.
Let's cut it short, guys. Let's have one more. one or two more questions, and then that's it.
I want to thank you for coming out. And you mentioned John Wheeler. Was he at San Diego State?
San Diego? No, he was at Princeton. And then when he retired from Princeton, he was at the University of Texas at Austin for a number of years. He passed away about 10 years ago.
Okay. One last question. This is really bringing everything down to earth in a very major event that happened on September 11th. With your knowledge of gravity, could you explain how Building 7 came down?
How building which?
Building 7? You don't know about that?
No, I don't know about
Okay,
that.
that was the third tower that came down.
8 hours later, a 47-story structure collapsed in 8 seconds.
That's possible.
And how about the Twin Towers? What is your explanation?
If you fly fuel-laden 747s into big buildings with inadequate fire protection, that's what happens.
Wow, okay, thanks.
Sorry. There's nothing deep, dark, or mysterious about what happened on September 11th.
Okay, question. Go ahead.
It was just a quick question about your book. What level of physics and math is needed to understand?
It's a mixture. There's enough physics and math in there so that people who are expert in the subject can see the real nuts and bolts, that it's not just a bunch of verbiage and baloney and stuff like that.
Okay.
That there's real mathematics and there's real physics. But it's interspersed with enough other material and descriptive stuff and stories about the path and all that, so that you can actually read it and enjoy it.
Okay.
You'll find chapters 4 and 5 pretty tough sledding. They're the experimental chapters.
Okay, that's it, guys. Let's give a warm welcome.
Thank you.
Dr. Woodward, we certainly appreciate you being here and driving such a long way to get here, and it was a great talk. Thanks so much.
Thank you very much.
Thanks so much. Appreciate it.
Thank you.
All right, you guys, we'll see you next